Hi there, here we go. We're going to explore angle pairs today, and there's lots of new terms. It's not really that hard of stuff, but there's so many new terms and words and angle pairs that you need to be familiar with, so put on your thinking caps. You've got to remember a bunch of stuff today. All right, and this little wavy border that I put on here, I put that on there so it'll stand out in your notes, because that's usually something that, hey, this is going to come back a bunch. You need to know this. All right, so, and today it's a whole bunch of words. Okay, so adjacent angles. We're talking about angle pairs here. So angles that have a common vertex and they share a side. So I've just kind of gone through these terms and shown you a picture of, this is kind of your classic adjacent angles. They have a common vertex and they share a side. These are adjacent. They're next to each other. That's what I think of. Things that are adjacent are next to each other. This is a special type of adjacent angle because it actually forms this straight angle here, but they still have this common vertex and they share a side. So these angles 1 and 2 are adjacent as well. A linear pair are two adjacent angles that form a straight line. So that example that I showed you actually has a special name. It's a pair of angles that form a line. So right here, your adjacent angles that form a line. Now, linear pairs are special because they form that line. If two angle pairs form a linear pair, then they are supplementary. Now here's another word. Now this one you probably have heard before. We'll add it into our notes here in a little bit, but supplementary means they add up to 180, which makes sense because they form that straight line. They're going to end up adding up to 180. But they call that the linear pair postulate. Sometimes we just write linear pair are supplementary. Now, linear pair postulate or linear pair are supplementary, either way, but I put this sticky note, remember, because that's going to be one that you actually are going to use. Like, you have to state this postulate right here. Say, oh, I know this because the linear pair postulate. All right, so a sticky note means even more important that you remember it. All right, vertical angles. These are the non-adjacent angles formed by intersecting lines. Anytime I see this big X of lines, like we have here, this big X, all right, that always forms vertical angles. They're the non-adjacent ones, so they don't share any sides, but because all four angles here have the same vertex, right here, they'll have the same vertex, but they're the ones across from one another. So angles 1 and 2 are called vertical angles. 3 and 4 are vertical angles. Complementary angles. This is two angles whose sum is 90 degrees. And complementary angles can be just totally separate from one another, like this, and they just happen to add up to 90. Or sometimes you're going to see them as adjacent angles, and you can see that this was a right angle, and then they threw in some ray in here to create two separate angles. Well, because it originated as a 90 degree, then of course these are going to have to be complementary angles. Supplementary angles. These are two angles whose sum is 180 degrees. And again, they could be two separate angles, or they might be adjacent angles where they're touching, and a linear pair would be a classic example of two angles that are supplementary because they're going to add up to that 180. An angle bisector. Now we talked about segment bisector in the previous lesson, or a couple lessons ago. Bisector means it sections it into two equal parts. So if you have some sort of an angle here, I have my angle XAZ. An angle bisector is going to be a ray that divides it into two congruent angles. This ray AI that comes out through here, you can see that I've marked these two angles are going to be congruent. This is an angle bisector, cuts it into two equal angles, or two congruent angles. Now, the tricky part, now that I threw all those terms at you, is can you look at a picture and identify what it is you're looking at here? So true or false here, with all of these different angles in here, it says angle B, F, and then D, so this angle right here, and C, F, D are adjacent. Well, here's the thing. these two are not considered adjacent because CFD is kind of a part of the original angle they gave us, the BFD angle. So like this little angle, CFD and BFC would have worked, yes, but not this one, not here, because that's caught up inside of the other angle. All right, so I'd say false on that. All right, let's try again. Angle AFB, okay, that's this one here, AFB. Remember, you just wrap around the angle. And EFD, EFD. Now, it says they're vertical angles. If you'll recall, if you look back, vertical angles are formed by intersecting lines. And I can see I have an intersecting line here and an intersecting line here. But this BF is not really a line, it's only a ray. It does not continue on. So to use this first angle they said, AFB, that's not going to work because this is not part of an intersecting line. I'm going to go false again. Last one, AFE and BFC are complementary. AFE is right here. That's 62. BFC is right here. That's 28. To say they're complementary means that they have to add up to 90. What do you think? Is 62 plus 28 equal 90? It does equal 90. So that one would be true. All right, let's do some algebra on this one. It says finding angle measures. Angle KPL and JPL are a linear pair. KPL is equal to 2x plus 24, JPL, blah, 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 blah. Lots of stuff there. They didn't give us a picture. All right, we have to draw our own picture this time. We have to use what we have learned here to draw this picture. And so let's start with that. Just that very first statement. It says that angle KPL and JPL are a linear pair. Notice that the vertex of this one is P and the vertex of this one is P. Okay, so a linear pair is going to look like this. It's going to have a straight line with a ray coming out of it, like that. And this point right here is going to be that shared vertex. They both have a P. Now, I have an angle over here on the left and an angle on the right, but if you look back up to the original again, they both had an L. Well, that L is going to have to be on this shared side then. So then I could have KPL, JPL. All right, let's fill in that. So L is going to be up here. I'll put K over here, and I'll put J over here. Now, I'm just kind of doing that randomly, so no promises that this is drawn to scale or that my numbers are going to look right for my picture. But that's what, in general, it's going to look like. Now it says the measure of angle KPL is 2x plus 24. 2x plus 24. And JPL is 4x plus 36. What are the measures of those two angles? All right. We actually did this in our previous lesson, but specifically we're doing it here because a linear pair is supplementary. We learned that. That was one of the things with the sticky note. A linear pair is supplementary. So if they're supplementary, that means they have to add up to 180. So let's go ahead and set this up and set it equal to 180. 2x plus 24 plus 4x plus 36 equals 180. All right, clean up the left side, combine your like terms. That's a 6x plus 60, it looks like, equals 180. Subtract the 60. Okay, hang on. You keep solving. I got to let my dog out. He's going crazy. Whoa. Okay, did you finish? All right, 6x, sorry, equals 120 divided by 6. X is 20. All right, now that's what x equals. Now what we're going to do is we're going to plug it back in to see what each of these angles is. So if I plug it in up here, I'd have the measure of angle KPL would equal, let's see, 2 times 20 is 40, plus 24 is 64. That angle is 64. Remember what I said about my picture may not be drawn to scale, because that's an obtuse angle. I only got a 64, so that's all right. The math is still there. The measure of angle JPL, now put 20 in there. That'd be 80 plus 36. That's going to be a 116. All right, there we go. Okay, last one. This is you try it on your own. Let me scoot that up. You go set this up and see if you can draw a picture and then figure out an equation to write or to solve this problem in some way. It doesn't really necessarily look like it's an equation one, but see what you can do with it. Take a minute and pause the video and finish it out. All right, this is what it should look like when you draw it out. Since it's an angle bisector, I've got my little congruent symbols to show these angles are the same. If one of them is 58, the other one is 58. That's what an angle bisector does. But the question is, what is the measure of angle DAB? That's the big angle. That's the two angles together. If I add 58 to another 58 there, I'm going to add the two together, I'd be at a 116 degree for that full angle there, measure of angle DAB. All right, that's all I have for you. Hope it helps.